Alright, I'm back to discuss the EMG file, or subfile. Last video just discussed about the header of the EMO file, and then the EMO file will point to subfiles, which are EMG files. So what I just deleted the top and the bottom off, just so we have one isolated EMG file, and I'll just discuss how we're gonna read one of those. And if you're gonna do your own like tool or something, you just like literate through all your EMG blocks this way. But anyway, yeah, we're just gonna isolate the EMG block and discuss the structure there. So yeah, in the EMG block, I highlighted some things just because I keep forgetting. So this green bit here, I don't know if I can toggle this crap off. Suppose not. That's okay. I kind of need them to understand anyway. So, yeah, this beginning block here is your EMG header. And of course, you start with the 4-character code, your file identifier. So it's a hashtag EMG. The numbers preceding this, again, not sure. Could relate to version number or something. However, going through the EMO file, this number here will actually change. So this number here, the 211, for some reason it will oscillate. It'll go back to 211 or go to a different number. I had thought this was the version, but because of that pattern that I'm witnessing, I'm not too sure exactly what it is. It could have to do with memory addressing or something. Not entirely sure. But anyway, based off this information, you have a preceding structure. It's dependent on the structure before it, or the file identifier. So for this file type, it's just this one offset, and then it just tails off, meeting with that 16-byte alignment. So this offset just tells us 16. That's just the size or the end or the next data section. What do you want to say? What do you want to call it? So it's just basically saying sorry. It's basically just saying oh, your data starts here now. Alright, so very simple header. It's just like 16 bytes. And then yeah, so this is it. The next data structure is the actual object. Now it begins with this red section here. This isn't even understood yet, this piece of code here. But just going over my my logs, my data dump, that number is here for each object block. So this block that we're looking at is right here. I picked it up in my program. It's 199 and 2. So if we look back at there, this is 199 and this is 2. Or you could perceive it as 711. Doesn't appear to be any type of file size because it's consistent across everything. So if it's not relating to the header itself, it's probably not relating to anything. It doesn't really go anywhere. Also, you can see there's a consistency. So 199, 199, 199, 199, 199, 199, 199, 199, 199. So when we're looking at data structures, we're looking for patterns. There's no pattern here. Okay. The other thing is that it's fixed. It's not variable. It doesn't change. It's a constant. So because it's a constant, it's almost impossible to kind of guess what it means. So as it is right now, this red thing is completely unknown. But not necessarily. I don't care. I don't care. Okay. So yeah, since it's a constant, if you're gonna write a new file, not completely necessary. Just leave it as a constant. The next number here is what is this guy? The material count. So this EMG is just containing an object, right? You can actually have it split up into sub-objects or elements, and then you can assign each one of those elements a material. All right. and the material is actually defined up in here. So depending on this count, you can have multiple materials defined. Okay, in this case, we're going to be defining one material. Next number here is completely unknown because, again, it's constant. It's always 0. We have no idea. It's probably a data structure that does exist, but I don't have an example of it, so I can't describe it. So we basically have these two complete unknowns, and we have this offset here. This is a material offset. So if we follow this, now remember this EMG header ended, so the data now actually begins from this one. All right, so we're going to jump from this position 50 over. And then this brings us to this data structure here. So this is our material data right here. All right, next offset, well, actually, I'm going to work my way down until I hit this area here. Okay, so this count here is the vertex count. Okay, so how many vertices are included? Okay, it's typical. This one is interesting. This is the vertex size. This just tells you the data structure you're going to expect when you read your vertex data. Okay, so each entry for the vertices, or one vertex entry, will be this size. So it's going to be, in this case, it's going to be 60 bytes. Then we have the, what's this guy? The vertex offset. So this is telling us where those vertices are located in this this file. So again, we jump off from 10, and here we go, the vertex buffer. Okay, that's that. And then the next number here, this is the what is it? Face type. There we go. So same thing with the vertice type or vertice size. We have this face type or primitive type. Primitive type. Basically, the polygons can be described in a indice list that is either unoptimized or optimized in strips. So we have triangle lists and triangle strips. So if it's 0, I believe it's strips. If it's 0, 1, it is list. All right, let me just double check. So I'm not completely full of bullshit here. Yeah, 0 is list and 01 is strip. So I had that backwards. Sorry. All right, next, this number here 2 is telling us, I believe, how many elements are inside this object. So in this case, we have one material covering 2 elements. All right, that's fine. And the last offset, I actually forget now. It's this one. So much crap in this header. Okay. This is the element offset table. So we're given a count of how many elements, and then the next preceding value here is the offset to each element, or to a table that tells us where the elements are. All right, so each sub-object, basically, if you want to say it that way. And then the next 3 lines here are, from what I can tell, there's some sort of transform. Not exactly sure why you would want to give your object a transform. But yeah, there's a transform here. So typical 4x4 matrix. So you have your cosine, and then you have your scalar value. Again, cosine, scalar value, scalar value. I think, yeah. So there's no position here. It's just not translation matrix, more like a rotational matrix. I think it could also be as well a no. This is what it is. When I wrote my tool, I entirely skipped this. I don't see any reason to having this unless you want to skew or like rotate your object. I don't know. I just skipped this data. It doesn't really seem to be important, but it's there. So it's not exactly translation. It's like rotation information. If that's what it is, I don't know what it is. All right, and then that's it. That is the EMG subheader. It's already packed in there. All right, so that's describing the following data structures below. All right, and then below that we have this other table here, and then it's just simple lists. So this offset here is actually given to us here, which is the material offset. So this is the material information. So immediately we have another offset, which ironically just offsets to the next value. So this is telling us where the material data begins again. So this is where the material data begins. So it's giving us a count. It's saying we have we have one material, right? And now we have a sub count for how many textures. So it's saying, okay, this material has 2 textures inside of it. Okay, and so now this is the texture structure. It's basically 4 bytes. I'm not sure why. These could be various texture flags. Okay, this one we know for sure is the texture ID. Okay, so for the first texture slot, all right, we have this second byte here. That's the texture index that relates to the EMB, which file to use. Which, ironically, they don't really have file names. They're just called 1 to whatever. So yeah, that's telling us the index of the texture. The rest of the stuff, no idea. Okay, some other flags, something to do with the texture, and then after that, it's preceded by 2 float numbers. So in my mind, they are probably X and Y scaling numbers. So if you want to scale on the X or the Y, you can, and that's what these values are. And I would, yeah, they would have to be. So that's the first texture. Then we have another texture here, another entry here. Same thing, texture ID, get that 4 bytes that describe the texture, and then the 2 floats for the scalar values. And then that's it. Okay. Now this structure here would repeat depending on this count. This is how many textures. Okay. And then this whole structure here, okay, the count and structure itself will repeat depending on your material count. So we only have one material. So it's this offset begins here, and these are your materials. Okay. And then we have this offset here, which is denoted by this offset. Oops. Which again is, I forget, what are you? Oh, it didn't really describe what it was. Oh, the element offsets. Sorry, I totally forgot. These are the offsets telling you where your elements are. So that is now officially beginning here. Okay, so let me actually just delete that. So this was the material data section. Okay. Now I'm pretty sure this will probably just again tail off with another 16-byte alignment. All right. So now this last little bit here is the element table, and this is also terminates at a 16-byte alignment. So these offsets, we got 80 starting again, of course, from this position. So we're going to jump from there, 80, and this brings us here. All right. So you can see we have up here we have the element count 2. All right, 2 elements, and then we have 2 offsets, and then yeah, just padding. So this brings us here. This is the first element, and down below will be the second element. I'll actually bring that up. Actually, it's right here, and that's starting from this position. Okay, and this is of course the second element. All right, so this is going to be repeated based on the element count. So right now, this is the data structure for each element or each sub-object, if you will. So that is basically you have 4 floats, and these for sure are position data. So this is your scalar value. It's always going to be 1, and you have position x, y, z. Now, when I plotted this in, it seems to be the center of each sub-object. I'm not even sure why that's important, because they don't give you a value for a bounding box or a sphere bounding or something like that. So again, not entirely sure why they bother with this data. Not important. So you can skip that. Not really important. And then you're followed by a little piece of stuff here. This is a little bit of code talking about the actual. It's a little header, basically, a little tiny subheader for this section. So we have this first one is your material ID. So it's saying which material to index to. So 0 in your array is going to be the first material. All right, so that's cool. Then we have the count for how many faces. Kind of odd that it's actually just a short, but that makes sense, I guess. So it's saying we have 1,041 faces that are basically defined down here. And then followed by that, we have this count here, which is 11. Now this is your bone palette, what do I call it? It's basically how many bones are gonna influence these polygons. Actually, let me rephrase that. It is, yeah, which bones you will be referenced to by the vertices. So down here will be a bunch of vertices, and the weight values will say, okay, at weight 1, or at bone 1, give me a weight of 10 or something like that. So this value doesn't relate to the actual total skeleton. It's just a mini skeleton. So it's saying you have 11 bones that are going to be affecting this mesh. Okay, and these bones are what you will have to add to your skinning. Okay, it's really confusing. I'll explain it later on, but yeah. And then followed by that, we have a set fixed size of 32 characters, which is the element name. Not exactly sure why it has a name. Could be the material name, I suppose, but it doesn't seem really like it has any material names. More likely it's an element name, but from my understanding, you really can't give a sub-element a name, so it must be really the name of the material, really, I guess. Anyway, so that's 32 characters fixed, so we just jump by 20 in hex. That brings us to about here. Now this is typical. Your face list will usually begin with 1, 2, 3. So we have 0, 1, 2, 3, 4, 5, etc. It's a face list, typical. This one, depending on this value here, 0 or 1, will be strips or triangles. All right. So because it's 0, 0, it's triangles. So it's going to be 1, 2, 3 as one face, 1, 2, 3 as another face, etc., etc., etc. Now, okay, so this value here, that the face count, is going to be 1, 104, 10, whatever, right? So we can take that count, and because the data size is a short, it's defined as a short. You can see that's 0100, which is just one integer. It's taking up 2 spaces, so we have to times this by 2, and we get this. So I can jump from this position, okay, by this amount. This brings me here. Now this is your bones are influencing or affecting the vertices down below. So you need this data. So you're going to read 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then it terminates with padding to the next 16 byte alignment. Okay. So you're going to take these in because when you get to the vertex skinning, if the bone or the vertex is requesting for a bone at 5, 1, 2, 3, 4, 5, you're going to have to request once you import it into your wherever you're importing it. The whole skeleton, you're going to have to pick out the bone ID 29 and weight that. So this is just I'm not sure what you would properly call it, some kind of map or something, or a bone palette to reference it to your actual skeleton. Okay. Anyway, so then you have that, and that's it. And then you have your other sub-object, and then that's defined. Let's see the count here. Oh, it's the same. So I can just jump from here. All right, and then we have that. So this vertex position would have been also described up here in the subheader of the EMG. Okay, and now just after reading those two sub objects, we will be brought to the start of that vertex data section. Okay, you would get the offset from your header, your subheader, rather than reading from your termination because of the padding. Okay, but yeah, this is the beginning of the vertex data, and so this one was a size of 60. So I can just type in 64. Actually, I think it was. Yeah. Okay, and then now we can see the data line up. So you can see here in the text display, the data kind of lines up in a pattern, and then we have these structures. Now, it's better to just describe these patterns here than it is to look at the code because the patterns are too large. All right, so based off of the code I looked at before from Peace Monty and Magnum, these were the structures that they were using. So because I only have one file, I can only look at the one size that I have seen so far, which has been the type 40 or the 64 bytes. The other ones I can't really vouch for, but yeah, they're based off the size. This one apparently is just X, Y, Z position, texture, UV, and that's it. All right, and these are just floats. So you have 1, 2, 3, 4, 5, 6, which total 232 bytes. 40 is pretty much the same. You got your X, Y, Z, your normal, and this one just has float. This one has no texture information, but then it has weighting information. So that's kind of mind-boggling. Then you have the type 40, which I understand is probably more favored because of what I'm seeing. It's comprised of your X, Y, Z position, your normal X, Y, Z, and you got your texture UV, and then this looks like a tangent, which makes sense because they use normal maps. So you have your X, Y, Z again, and then you have what looks like a vertex color, which is again red, green, blue, A, alpha, and then you're followed by 4 bone weights or bone indices, which you have to look up on your bone map to get the actual skeleton value, and then you got your weights, which there's a little bit of culling that I do to make sure I'm not grabbing an invalid weight. So I do a cutoff at 0.001, just some basic if logic. If it's less than this, don't include it. All right. I was getting some bad weights somehow based off how they were storing their weights. So yeah, that was it. That's the vertex structure. So you would read the vertex structure, and you would just combine it with your object stuff, and you're good. Yeah, that's pretty much it. Yeah. So that's your object structure. That's it, I guess. Not many unknowns actually. The only unknowns are these two pieces of data. Everything else is known. And from what I can tell, you don't. There's no way to link the shader information from here to the EMM file, and the EMM file doesn't seem to link to the EMG file. So a little bit confused on how all the files, the separate files, kind of go together. But yeah, this is the data, the geometry block section. So the next video, which I'm sorry this one ran so long, I'll discuss the skeleton structure. All right.